So, Dr. Brent, you can already start sharing your presentation. Just give me 2 seconds to present you to the audience. So Dr. Brent Mittelstadt is, Professor Brent Mittelstadt is a Director of Research, Associate Professor, and Senior Research Fellow at the Oxford Internet Institute. Coordinates the governance of emerging technologies, a research program which works across ethics, law, and emerging information technologies. He leads the trustworthiness auditing for AI project, a 3-year multidisciplinary project to determine how to use AI accountability tools most effectively to create and maintain trustworthy AI systems. And he also serves as an advisory at the advisory board of the IAPP AI Governance Center. So whenever you're ready, Dr. Brent.
All set.
Should I?
Just checking, is everything working okay on your side?
Yes, from our side, we're set. Please continue. Thank you.
Fantastic. All right. Well, thank you so much for having me today. I'm really delighted to kick off the event today and to just say a bit about sort of the importance of explainable AI in the context of EU regulation, and also to tell you a little bit about some of the work that I have done in this area, along with my wonderful colleagues at the Oxford Internet Institute, one of whom will be speaking as well later on. I just saw a note about no sound. Can I just, okay, but yeah, I just confirmed sound is okay. So today, what I'm going to just introduce is where the notion of explainable AI and transparency crops up in EU regulation currently. Looking back first at the GDPR and then also the AI Act, and then just introduce some key distinctions in the context of explainable AI to hopefully kickstart the discussion today and inform some of the panel discussions later on. So just to quickly introduce where we see requirements around explainability and transparency in the EU. Of course, you couldn't talk about this without talking about the General Data Protection Regulation. And even in that regulation and going back to the 1995 directive, there were already requirements for transparency and notification around automated decision-making and automated processing. And so we won't go into these in great detail, but just to say what those sort of requirements look like. Across Articles 13 to 15, you have a set of notification duties and the right of access, which give you a right to be informed about the existence of automated processes, something about functionality, also meaningful information about the logic involved in any automated decision making, as well as information about the significance and the envisaged consequences. So that gives you some basic information about sort of the overall functionality of the system, what it's designed to do, its existence, and we'll see some of those things mirrored in the AI Act as well. There's also Recital 71, which introduced the idea of a right to explanation of automated decision making, but there's really no further explanation of what an explanation would actually entail in the context of the law. But thankfully, we've had some very good guidance issued by data protection authorities across the member states and here in the UK. There are other transparency requirements that relate to AI and automated decision making, including Article 19 and Article 35, and I'm sure that there are others that are missing in there. Moving on to the AI Act. So the AI Act introduces a number of, let's say, complementary transparency and notification requirements. And explicability itself is sort of a core concern of the Act. So we had the ethics guidelines for trustworthy AI produced by the high-level expert group on artificial intelligence. These were very, very influential in the formation and in the sort of general approach taken under the AI Act. And one of the key principles there is explicability or explainability, and it is linked specifically to having trustworthy AI systems or trustworthiness in AI systems. In terms of what the AI Act actually requires, in terms of transparency and explainability, it distinguishes between high-risk systems and non-high-risk systems. For high-risk systems, it introduces a number of transparency, documentation, and traceability obligations. And the idea here is really to help facilitate audits, to ensure that individuals can seek redress of fundamental rights violations, and also to fulfill supervision and enforcement authorities' mandates. So the obligations, whereas in the GDPR they're very much contained in certain articles, these obligations sort of cut across the act itself. And I listed a number of articles here that have specific obligations, but just to say they're things like the creation and maintenance of technical documentation, record keeping, logs, provision of information to users, conformity assessments, and also very specific transparency obligations for certain types of AI systems, including those that interact with natural persons, emotion recognition, biometric categorization, and deepfake systems. And there is also, of course, the EU database to register standalone high-risk AI systems, which also serves some sort of transparency function. And non-high-risk systems do also face some transparency obligations, but they're very limited in comparison. I think going back to these guidelines, it actually raises a really important first distinction that will be very, very relevant across today, which is the difference between trust and trustworthiness, or trusted AI versus trustworthy AI. And so you can draw a distinction between systems and providers that are trusted, whether they deserve to be or not, and systems and providers that are trustworthy or actually deserving of our trust because they've somehow demonstrated their trustworthiness through transparency, through testing, through a commitment to safety, or other means. And so the aim really of the Act and the aim of these guidelines is to regulate the development and usage of AI systems so that they are deserving of our trust, meaning that our trust in them is not misplaced or coerced in some way. So I think it's important to maintain that distinction between systems that are merely trusted and those which are actually trustworthy. To move on to a couple of key distinctions in the context of explainable AI. The first obvious one here would be between transparency and interpretability. I should say the way I will distinguish these two is certainly not universally accepted. It is just something that I found particularly useful. But I think of transparency methods as something that helps explain the environments and the processes through which a system is designed, developed, used, and governed. And so some examples of those sorts of methods would be things you see on screen here. So things like data sheets, model cards, impact assessments, and also the trustworthy AI assessment list that was developed again by the high level expert group, where the idea is basically it's a set of questions that you are supposed to ask yourself about the systems that you're procuring or developing or using to assess whether they are trustworthy and have been developed in a trustworthy capacity. Interpretability is a bit different. So interpretability methods would be things that explain the functionality or behavior of models. So the basic assumption here is that AI systems are in some way incomprehensible or not fully comprehensible to human observers because their internals or their rationale are unknown or inaccessible to the observer. Um, and interpretability in the narrow sense that I'm using it here, refers to the capacity to understand the functionality of a model. And in the case of a trained model, in the case of an AI system, to understand its outputs and generally how it produces outputs from inputs, and to be able to explain that process in human understandable terms. Now, there are a number of further distinctions that I think are very helpful in the context of interpretability specifically. So we can distinguish between explanations of model functionality, which address the general logic that models follow in producing outputs from a set of inputs. And you can distinguish that from explanations of model behavior, where the aim is to explain how or why a particular behavior exhibited by a model occurred. For example, how or why a particular output was produced from a particular input. So explanations of model functionality aim to explain what is going on inside the model, whereas explanations of model behavior aim to explain what led to a specific behavior or output by referencing some of its essential attributes or influences on that behavior. And in that case, it's not strictly necessary to understand the full set of relationships, dependencies, and weights of features within the model in order to explain specific behaviors. So that may make explanations of model behavior up front at least a bit more feasible. We can also distinguish between explanations as approximation models and explanations as explanatory statements. So approximation models would be a type of simpler human interpretable model that is created to reliably approximate the functionality of some more complex model. And that approach contrasts with explanations and the way that the term is used in the context of philosophy of science and epistemology and in the cognitive sciences, where typically what we mean is a explanatory statement. So a statement that explains the causes of some phenomenon that we are interested in. We can distinguish as well between global and local interpretability. That just refers to the scope of the model or the outputs that you are trying to explain or make human comprehensible. And generally speaking, global methods will aim to explain the functionality of the model as a whole or across a particular set of outputs in terms of the significance of features, their dependencies, their interactions, and their effect on outputs. Whereas local methods try to address, for the most part, the influence of specific areas of the input space or specific variables on one or more outputs of the model. And then finally, we can distinguish between intrinsic and post hoc interpretability methods. And basically, the distinction here is we can achieve interpretability by changing the design or restricting the complexity of a model, which would be an intrinsic approach, or by applying some methods to analyze and explain the model after it has been trained and deployed. That would be post hoc methods. And so there's a number of methods that do or that fit within the context of interpretability. There's a wonderful online textbook by Christoph Molnar that is updated over the years and goes into all the different sort of general approaches that we have to interpretability. So if you're interested in the particular methods, highly recommend looking at that textbook. But so these are some of the methods we can use to make models more interpretable or to explain them after the fact. But the other approach we can take would be to just not try to explain these systems at all, and instead use interpretable models up front. So abandon the usage of high complexity or very complex models, maybe just in high risk scenarios or high risk use cases, and instead only use interpretable approaches instead. This is something that Cynthia Rudin has argued very convincingly. And so then finally, I just want to look at what makes a explanation good. What sort of requirements can we find for good explanations in practice? And this particular section is based on some research that I've undertaken looking specifically at the requirements for good explanations. And so the first question you can ask yourself is, what exactly is it that needs to be explained? So explanations could address many, many different questions. And which question is most relevant may depend on the person that's asking it or the specific purpose for asking it. So I may be interested, for example, in why the system behaved in a certain way. I may want to know whether the system is working as intended, or look at whether the decisions that are being produced by the system seem sensible or conform to relevant legislation. I may be interested in explanations to investigate the fairness or potential biases in the system. Or maybe I just want to know what I could do differently next time to get a favorable outcome. And of course, answering those questions is very, very difficult because quite often we're dealing with models where the internal state is composed of millions of interdependent values, where it may simply be too complex for humans to comprehend. It may not be possible to completely understand the full decision-making criteria or rationale. And so we can turn to philosophy and to cognitive science for some help here to evaluate what actually makes a good explanation. So in the philosophy of science, we distinguish at a very basic level between full or scientific explanations and partial or everyday explanations. And what we mean by an explanation here is just a statement about the causal chain and the necessity of causes that lead to an event. So we may try to give a full account of the causes that led to a given event or phenomenon, or we may just be interested in some partial version of that, some incomplete version of that. And so everyday explanations is typically what we're talking about in the context of XAI. And everyday explanations focus on why particular facts, so events, properties, decisions occurred, rather than focusing on some sort of general scientific relationship. Seems pretty evident that when we're thinking about explainable AI, we're trying to explain something in just a everyday partial sense. And so there was some wonderful work done by Tim Miller in 2019 that looked at evidence across philosophy and cognitive science and came up with a set of requirements for what makes good everyday explanations drawing from those fields. And what he said is that everyday explanations are those that are contrastive, selective, and social. So just to quickly explain what those criteria mean or what those characteristics mean in practice. So the contrastive aspect of it means that we typically seek explanations in response to some counterfactual case. So as Tim Miller says, people do not ask why event P happened, but rather why event P happened instead of some event Q. Um, and so it's been shown in the evidence that was reviewed by Miller, it's been shown that people tend to prefer explanations that are contrastive, and it may be because of the complexity of the explanations, or just the fact that when something abnormal happens, that is the thing that drives the request for an explanation. So when something that we don't expect to see, or when there's some sort of violation of social or ethical norms, or just when something out of the ordinary happens, that tends to be when we would ask for an explanation, as opposed to when things occur as we would expect them to. In terms of the second criteria, selectivity, what this means is that full causal explanations are exceedingly rare and not expected. Rather, there will be certain causes that are selected as relevant according to the needs or the requirements or the motivations of the person that is asking for an explanation. And so, for any given event, for any given outcome, for any given decision of an AI system, any output, you'll have multiple possible valid explanations of how that thing came to be, but certain ones will be more relevant than others. So if I'm asking, for example, why a glass broke, one valid explanation would be because gravity exists. Another valid but partial explanation would be because marble is harder than glass. But the reason that I'm asking the question is because I want to know who's responsible for breaking the glass. And so the most relevant explanation for me would be the glass broke because my cat knocked it off the table. So again, all of these are valid explanations, but certain ones will be more relevant to others. And it's worth bearing that in mind when we think about how to implement explainability methods in AI systems, because quite often we treat it as a homogeneous issue where everybody would be satisfied by the same sort of explanation. And that's simply not the case. You have to take user requirements into account. And finally, good explanations are social. Essentially, what that means is explanations are interactive. So the information will be tailored according to the recipient's beliefs and level of expertise. And ideally, good explanations are a discourse, they're iterative. It's not a one way exchange of information, it's more like an argument or a conversation. And we should expect disagreement and confusion. Again, the idea that we can have systems produce explanations themselves and give them directly to users or affected parties, while that may be helpful, that will arguably not be enough to give a fully satisfying or good explanation, because we would expect to be able to question it, to ask follow up questions, to request further information, or to redirect to say, that's not the thing I'm interested in. Actually, I want to know about X or Y. And so later on, you're going to hear about an approach that I had a hand in developing from my colleague, Professor Sandra Wachter, about our preferred approach to do contrastive, selective, and social explanations called counterfactual explanations. So I won't go into that here, but just to say that that will be discussed in the final panel of the day today. And the picture I've given here is by far an incomplete picture of how we could possibly evaluate the quality of explanations themselves. So we have those three criteria: the contrastiveness, the abnormality, the selectivity. But we may also be interested in things like the relative complexity of the explanation, its sparsity, whether it's novel in the context of other explanations that have been given, whether it's true. We quite often assume that the explanations we'll receive are true, but that can't necessarily be taken for granted. We may also want to know about the representativeness of the explanation. And you may feel, for example, that you're not being told about a particular relevant cause of an event, but rather being given a more mundane or socially acceptable cause of that event as an explanation. And we could also be interested in the fidelity and the consistency of the explanations that are produced across a system's lifespan. And we can also think of this in terms of evaluating the quality of giving explanations. Here, we might be interested in how interactive and usable is the process by which explanations are given to people. Are the explanations locally relevant? And is it locally comprehensible? Are we basically giving them at the right level of detail or the right level of expertise? And just the final thing to conclude with would be just a bit of a reflection on the relationship between explanations and justification. I think it's worth bearing in mind that explanations and justifications are two different things. Of course, they connect to each other, but explaining how something happened is not the same as explaining why something happened or whether the thing that happened is actually justified. Fully transparent decisions and systems are not necessarily good decisions and systems. In our own work, we went down exactly that path. We did quite a bit of work on how to give good explanations in the context of the GDPR. And then we realized, even in the best possible scenario, even if you have the best possible explanations, that's not necessarily going to lead you to a justified system or to a system that seems reasonable to you and where you can actually query the justification or the justifiability of the system's behavior. So I will end there. I thank you so much for your attention, and I'm really looking forward to the panels today. I think we have an absolutely fantastic event ahead of us. So thank you, everybody.